Alright, so today's notes are right after that deltas daily activity. We talked about triangle congruence. Today we're going to talk about side, 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 and side, angle, side. Quick little warm-up. Again, try it on your own first. Make sure you understand. First, name the angle formed by ray RS and ray RT. If I draw that, there's ray RS and ray RT. The name of that angle is SRT. Of course, you could have put TRS, or you could have also put angle R. Name the three sides of triangle ABC. Well, I drew it for you. There's triangle ABC, the three sides AB, BC, and AC. And in the triangle DEF, name the included angle for segment DE and FE. Well, there's my triangle. There's DE, there's FE. The included angle, the angle between those two segments, is angle E. Alright, this we've been doing. Triangle congruence. This part is not new. We talked about what makes triangles congruent. What makes triangle, or what makes any polygon congruent, but then specifically this was talking about triangles. If triangles are congruent, then all my three sides, they're corresponding, and they're all congruent. Again, the order does matter. So side SQ, this side of this triangle, matches up with side MN from this triangle. Side SR from this triangle matches up with ML. QR matches up with NL. And if my triangles are congruent, again, all my angles also match up. Angle S matches up with angle M. How do I know that? Again, look, angle S is between 1 and 2 tick marks. There's angle S. Over here, 1 and 2 tick marks. There's angle M. Q matches up with angle N. Angle R matches up with angle L. So this is the stuff that we have been doing. If we were talking about, if you want to show triangles are congruent, you must show that all your angles are congruent, all your corresponding angles are congruent, and all your corresponding sides are congruent. With that deltas daily activity, we tried to show you guys that there's shortcuts that we can take. So we don't have to show that all the sides and all the angles are congruent. We can do what is called side, side, side. If three sides of a triangle are congruent to three sides of another triangle, then the triangles are congruent. So it's sufficient, it's enough for us to say, if these three sides of triangle 1 match these three sides of triangle 2, it's enough for us to say those triangles are congruent. We don't have to know about the angles. We can just know about the sides, and if the sides are all congruent, the triangles are all congruent. So again, we just match up here again. Again, the order does matter. The three sides do match up. Side PQ matches up with side ST. Side QR matches up with side TU. And side RP matches up with side US because of the tick marks. Again, this side matches that one, this side matches that one, and this side matches that one. Because all the sides are the same, even though we know nothing about the angles from the picture, it's enough just knowing that the sides are the same to say by side, 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 these triangles are congruent. So you have to be able to use that language. If you're asked, what postulate would you use to say that these triangles are congruent, your answer would be side, side, side. And the other shortcut we're going to use is called side, angle, side. If two sides, not just any angle, but the included angle, the angle between those two sides, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So we look at our picture, and again, it tells, because of the tick marks, I know that HK matches up with LN. They each have one tick mark. So there's my side. The angle K matches up with angle N. So these two match up. These two are congruent. And then KJ matches up with NM. So I have the two sides of the triangles matching up. These two sides match. These two angles match. And these two sides match. So by side, angle, side, I'm able to say these two triangles are congruent. Two practice problems in the back. It gives you two triangles, it gives you a congruency statement, and it tells you that x is 3. So the first thing I did was I put in, okay, if x equals 3, what does that mean? Come over here, well, if x equals 3, then x, this side is 3. 3 times 3 is 9. 9 minus 5 is 4. And 3 minus 1 is 2. So now I know all these sides. So I can say UV is congruent to YX, and they are both 4. UV, YX are both 4. VW is congruent to XZ. Just look at the picture. I can also use my statement. And they're both equal to 3. And UW is congruent to YZ, and they're both equal to 2. So what postulate, what am I using? Again, I know nothing about the angles, but it's sufficient for me to say by side, 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 these triangles are congruent. If I know all the sides match up, I know my triangles are congruent. We'll do the same thing down here. It gives me this statement. It tells me the y is equal to 7, so I plugged in. 3 times 7 is 21. 21 plus 3 is 24. So I know that HG is 24. 2 times 7 is 14. 14 plus 1 is 15. So I know GJ is 15. And this angle G, is 12 times 7 plus 42, which is 126 degrees. So now let's match up. I know that DE is congruent to JG. They're both 15. DE is 15. JG 15. I know the next angle, the angle in the middle, this angle G, angle E and angle G match up. They are both 126 degrees. And then I know that EF and GH are both 24. So by side, angle, side, these triangles are congruent. By side, angle, side. The two sides are the same, and the included angle are both congruent.